So you're going to have to know the directing effect stuff. So remember, activator versus deactivator. The only thing that tells you is whether something is a donating group or a withdrawing group. And then we have ortho-para directors versus meta-directors. So ortho-para directors are going to direct a new reaction to place the new substituent on either the ortho or para positions, whereas the meta-directors would direct to the meta position. So that being said, why do ortho-para directors direct to those specific spots? Yes. Okay, there's more space sterically. Yes. Yes, so resonance is a huge, huge part of directing effects. So specifically for ortho-para directors, what charge do we get? Negative, and what position do we get it on? Ortho-para, cool. So the ortho-para positions become what? More nucleophilic or electrophilic? More nucleophilic, cool. So the meta-directors, what charge do they have? Positive on what positions? Ortho-para. So something that students often will get mixed up on is all the resonance will land on ortho-para positions. So it's not going to land on the meta position. The difference is meta-directors have a positive charge that lands on the ortho-para positions. So by default, which position is more nucleophilic? The meta, yes, awesome. So any questions about general directing effect stuff? Yeah, so on benzene rings, all the resonance structures will give a charge on the ortho-para positions. It just depends on whether it's negative or positive. Cool. So I don't know if last exam you had just resonance questions. Everyone's like, I don't remember last exam. That's okay. So there's probably going to be one question on this exam that's something like this. I wish this would work with me. Okay. So let's say we have a benzene ring, and let's say that benzene ring has a methyl right here. What is the common name of this benzene ring? Toluene, cool. And let's pretend that we chlorinate this benzene ring. What reagents would we use for that? Cl2 and FeCl3. So what is FeCl3? It's a Lewis acid catalyst. Heck yeah. Okay, cool. So when we do that, we're going to end up with a chlorine added to what position? Ortho or para? Cool. So I'm going to draw two possible answers. We can have the ortho product, or we can have the para product. Cool. So this was just for review, but he could ask you a question where he gives you the different resonance structures of perichlorotoluene, right? So it could be plus and whatever, 4 or 5 different drawings of this, right? You want the plus charge to be, what is the best position for a positive charge? Outside the ring, but what's the name? For that special position that's right next to a benzene ring? Close. Okay, so there's something that's better, and then there's allylic, and then what's after allylic? Vinylic sucks, so that one's all the way at the end. Yeah, so tertiary, secondary, primary. Does anyone remember the one that's even better than allylic? I said it. Yes, benzylic. I said it. That's my bad. So when he asks you these kind of questions, he's asking to see if you can find the benzylic or the allylic position, right? So in these kind of resonance questions, you're not really going to have the benzylic position only because he's not going to give you like a longer carbon chain or whatever. So you're looking for something that looks like this and has a plus charge here. So why is that a good cation? It's tertiary and something else. Let's just take a look at what the allylic position is. Yeah, it's double allylic. So double bond, 1 carbon away, double bond, 1 carbon away. So this position has double allylic and it's tertiary. So if he were to ask you like what's the best positive charge or the best resonance structure, you want to look for something that looks like this. Cool. Are we sort of kind of okay with that? What? Yeah, so the chlorine, well, okay, so the chlorine is fine because here we would also make a double bond to chlorine. The biggest thing we're talking about is this guy. So here we have allylic and secondary, but here it's double allylic and tertiary. No, but this one isn't benzylic because you need all 3 double bonds in the benzene ring. So like this is what benzylic would look like. And I know you can't see it, but I'll move it over. So benzylic would have to be like a whole benzene ring and then the carbon next to it. Yes. I'll find the question. So there's going to be a plus charge on chlorine anyway because it has an extra bond, but you're looking for the other plus charge. It's fine. I'll find the question. It's fine. I feel like I'm not doing a good job of like verbalizing it, but I'll pull it up in a second. The concept of benzylic, allylic, tertiary, secondary, primary. Does that make sense? Okay. The same rule also applies when we're talking about acidity. So something he's probably going to ask you on this exam is like, he'll give you a compound. He'll say like, which of the following is the most acidic proton? Did he do an example like that? Okay, cool. So I will pull up that example and do it, but just know when we're talking about acidity, what's better than benzylic is the alpha position. So there's like an added molecule or position, I guess, for acidity trend versus carbocation trend. Yep. I mean, I guess in later chemistry classes, you can apply it to other things, but for this class, it's just acidity. Okie dokie. So I have this drawn out for you guys just in case, but all right. So you have to know this, knowing the order of most reactive to least reactive is going to help you because he's going to have the tri-substituted ring where there's like 2 things already on it and you're adding a 3rd substituent. So when we have 2 things on the ring, how do we decide which one is the director? Whichever one is the most reactive or the strongest activator. Cool. So if I gave you an example like this. We have an OMe group, and then we have a methyl. So which one would be the strongest activator? Oxygen or methyl? Oxygen. Why? Okay, yes. So there were a couple of really good things that people said. The biggest takeaway that I want to highlight is the lone pairs. So it can donate through resonance. So it is the more activating group. So that is the director. So where are we going to go in reference to the OME group? Ortho or para? Cool. So we have ortho, ortho, para. So do we have 3 potential spots? No, why not? Yes. So if it's between 2 pre-existing substituents, it's not going to go because it's too sterically hindered. Yes. 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 So that is one of my least favorite questions in this whole freaking class. So the difference between theoretically versus actually is theoretically how many spots are there that could be substituted. Theoretically, there's 3. But in reality, how many will be substituted? 2. So if he says the word theoretically in the question, you count all 3 of them. If it doesn't say theoretically, it's only 2. So I hate that question. I hate it so much. Just know if he says theoretically, you count that one that you cross out. If he doesn't say theoretically, you don't count that one. Okay. Everyone looks so sad today. What's wrong? Are we okay? Okay. Oh, that's true. That's true. I don't have to take these. I'm kidding. Okay. Moving on. What? Yeah. So I used to, it's okay, guys. No, I know. I used to like come and proctor because like, you know, why not? Now I just kind of hang out, work on lesson plans. Yeah. Don't worry about it. I don't. What? I guess so. Oh, you guys are cute. Yeah, guys, cheese. Okay. Ignore me while I take a second to do that. Okay. So some of the practice problems that might be similar to the ones on your exam would be something like this. So you already have 2 things on the ring and you're trying to add something else. So this is a special one and we might have forgot about it up until now, but some people got really excited. So I see that maybe not everyone forgot. So why is this one special? Yes, but how do we know that? I guess that should have been my question. Cool. So we have NH2 and why? Because we could have like NH2 and Br2 and we only add 1 bromine, right? So why is this one different? Think about the catalyst. What's the catalyst? Water. So if you guys remember this, like the trick, I guess, for knowing when you're doing multiple substitutions is if you have NH2 and water. So that's the combination that tells you that it's going to be multiple substituents. If it was just FeCl3 or FeBr3, you would just add Br 1 time. So if we have NH2 and water, we're going to add 2 bromines, and someone already said it, we're going to add it to both of the ortho positions because NH2 is more reactive than chlorine, and also the para position is already taken. But if the para position was not taken, we would also add it a 3rd time. Cool. So the answer would be number 2. Yes. Yeah. Yeah, SD just means strong deactivator, and then like WD is weak deactivator, and then A is activator. Yes. I'm so sorry. What? Oh, great question. Okay, so the reason we focus on NH2 more than the Cl is every single time we see a question that has 2 substituents already on it, we want to think, all right, how do we define each of them? So NH2 is a strong activator. The only reason I'm putting strong is because this is the strongest activator, and it directs ortho-para, whereas chlorine is a weak deactivator, and it also directs ortho-para. So to figure out which one is the director here, we have to figure out which one is the strongest activator. And by strongest activator, if you look at the list I had up here before, you're looking for the one that's like the highest activator or the least deactivating. There's a lot of different ways you can say that, but basically the strongest activator. So between these two, your strongest activator would be NH2. So you kind of ignore the chlorine. I feel like I said the same words over and over again, so does that make sense-ish? Okay. Was that a question, or are you just fixing your glasses? Okay, cool. Okay. Cool. Yes. That's a really good question. So in case anyone didn't hear, the question was, if NH2 is a strong activator, why doesn't it work with Frito-Crafts? And the answer is, it's actually such a strong base that if it reacts with Frito-Crafts, this base is going to react with a carbocation, and it does an acid-base reaction. So it's one of those like random things that is not the same reason as like a strong deactivator, but they just happen to fall in the same category. So it's a really good question. All right. So, okay. So for this, oh my goodness, what is happening? Yeah, what? I know you can see the answer. You know, leave me alone. Okay. So which of these liquids would be unsuitable as an inert solvent for the Frito-Craft reaction? I know I've done this once before, so if you're sitting here like, duh, I know what this means now. It's complicated. So when he says it would be unsuitable, okay. Today's a train wreck. That's okay though. All right, so which one would be unsuitable as an inert solvent? So he's basically saying inert solvent does not react. So he's saying which one is not going to not react. So essentially he's asking which one does react for Frito-Crafts. Again, this is one of the stupidest questions this semester, and I hate it because the wording makes like no sense. So if he says unsuitable as an inert solvent, he's essentially saying which one of these can work in Frito-Crafts. So we know that the only things that can't work for Frito-Crafts is NH2 and a strong deactivator. So we're trying to find which one of these guys is not NH2 and not a strong deactivator. Does that make sense so far? Yes. It is a weak deactivator, so it works. So weak deactivators do work, strong deactivators do not. Plus, if we looked at the other ones, so nitrobenzene has an NO2, acetophenone. What's that? Close. Ketone, because it has own. Awesome. So acetophenone would look like that. Ta-da. And that's a strong deactivator. And then trifluoromethylbenzene, that's just this. Nitrobenzene is yes. So the only weak deactivators are halogens. Inert solvent basically means it's going to be in the reaction and not react whatsoever. Yes. In terms of deactivators, yes. The only deactivators that work for Frito-Crafts are halogens, and then all of the activators besides NH2 work. Okay. repeat like the last thing. Yeah. So the only deactivators that work for Frito-Crafts are halogens, and then all of the activators besides NH2 are going to work for Frito-Crafts. Yeah, so inert solvent means it's not going to react. And if it's unsuitable at not reacting, that means it will react. So we're looking for the only one that can react, which is A. And then the next one is like asking the opposite, and it's saying like which one does not normally participate. So what are we looking for? Anything that violates the rule. Cool. So chlorobenzene, we know we just said that that will work. Regular benzene, that's obviously going to work. Toluene, what's that? Maybe not a strong activator, but it is an activator because it looks like this. Ta-da. So cross that out. And then tert-butylbenzene. That's just another R group, right? So the only one that won't work is nitrobenzene because that's NO2. Yes. Except NH2. Because NH2 acts like a base. It's a really strong base, so it won't react properly. Yes. Not necessarily because NH2 is the strongest, but you're looking for anything that violates the Frito-Crafts rule. So either NH2 or a strong deactivator. Yes. Yes. There you go. You are very welcome. You want to fight? I'm kidding. Oh. Oh. Yeah, I just, so much practice. I waste so much of my time doing this nonsense. Oh. Okay, we just did like 8 of those. Okay, I love this question. Oh, that's way too zoomed in. All right. I love this question and everyone hates it, but I think it's like the best trick question. Because it's not that hard, but everyone gets it wrong. Okay, but you're all gonna get it right because we're gonna do it right now. So the question is asking, which of the following is going to give you the product indicated in a substantial amount? And then it says greater than 50% yield. All that means is major products. So it's basically saying which of these are going to react and produce the product that's shown here as the major product, right? So all of these reactions, 1, 2, and 3, are what kind of reaction? They're all Frito-Crafts, and they're all alkylation. So I'm going to write on the side, or maybe I won't, Frito-Crafts alkylation. And so for the first 2, what's wrong with them? They have NH2. So automatically we know that 1 and 2 cannot happen because they have NH2. So bam, bam. Those would be no reaction. And then everyone's like, cool, so that means 3 is going to work. There's my answer. And then they go about their day. Wrong. Okay. So the reason that's the wrong answer is because if I draw this out, CH3, CH2, CH2, Cl, I know the carbocation that this gives me is this. That's not the best carbocation we could possibly have. So we do a rearrangement and we get this. So if this reaction were to happen, the actual major product would be this. Whereas the product they gave you, let me zoom out a tad so I can draw it. What they gave you was this. So this would not be the major product. This would be. So in reality, all three of these guys are wrong, and the answer is none of the above. So see, it's like a trick question, and a lot of people like fall for it, but it's really not that bad. But now you won't on the exam, so. Just some of them just annoy me so much, like theoretically. Who cares about theoretically? It's so annoying. Okay. Alrighty, let's do this one. And I just figured out how to cross out the answers without you guys seeing it, so haha. I know we've done this one before at the last exam review, but we're going to do it again. So this is one of the examples where he gives you excess and then people freak out and then excess doesn't actually mean anything. So we're just going to cross it out. The way you know that excess doesn't mean anything is because all of these answer choices only have one methyl group added, so it doesn't mean anything. Also, you could just know, like, conceptually, Frito-Crafts is already going to have polysubstitution, so you don't need excess for that to happen, so not a good choice. So whenever you see something like this where you have two rings, I know there's like 10 of these in the practice problems, you're basically going to split it up as if you had two completely different benzene rings. So you have A and you have B. And this is a Frito-Crafts alkylation. So one of the rings has a deactivator, the other one has an activator. So ring A is directly attached to a carbonyl, which means it's a strong deactivator, whereas ring B is attached to a nitrogen that has a lone pair. So that's an activator. Maybe that was not a good call using A and B. So I know a lot of people will be like, but that's literally the same functional group. Yes, it is, but the two rings are attached to the two opposite ends of it, and esters and amides, depending on which end you're attached to, can be either activators or deactivators. So what I've done so far, is that sort of kind of okay? All right. So we know that Frito-Crafts can't happen if there's a strong deactivator present, so we get rid of ring A. Ring A is useless, but ring B is not. And the other question people ask me is, okay, but this is an NH. So why doesn't that work the same as NH2? NH2 is all by itself. This is part of a carbonyl functional group. So they're not the same. That's the short answer. All right. So at this point, if we have an activator, where do they direct? Ortho, para. Cool. So the answer could either be here or here. Which one matches? Number 5. Yes. I mean, it could be either, and actually the right answer is para, but theoretically speaking, it could happen to either one. Para would be more favorable because of less steric hindrance, but both could happen in theory. Good question. You could also look at this and be like, okay, well, A, B, C all suck because they're on ring A, and then you're really only between D and E, and then the best answer here is para because this one is meta, so it sucks. Any questions? Alrighty. Love the empty space. All right, this is another question that I really like, and people often get very upset at it. I believe we've done this one too previously, but this is one that shows up on the exam. Did this one show up on your last exam? No. Okay, cool. Then it's either going to be on this one or the final. So if we see something like this, we automatically know what reaction. Frito-Crafts. Okay, and then also anhydrous aluminum chloride is just AlCl3. He likes to be complicated. So if we're reacting that with benzene, first thing we do is what carbonyl, what carbocation does this make? This. That's That's a primary and a four-membered ring. That sucks. Okay, so we could either do a ring expansion or we could do a hydride shift. Why is a ring expansion better? Is it easier? It's much more stable. So the four-membered ring sucks so bad that even though we can move this charge over and get tertiary, that's still going to suck. We want to get rid of the four-membered ring. So if you know that, you can already get rid of this and this. And we also know that if we're doing a ring expansion, we can only make the ring bigger by one carbon. So if we have a four-membered ring, we're going to end off with a five-membered ring. So we can also get rid of this guy. So just with logic, we've gotten rid of 3 of the answer choices. And if we were to actually do this ring expansion, we would get this. And when we add this to the benzene ring, we are going to get this. The reason I'm drawing out is because a lot of people forget this bond. Oh, just kidding. You can't see it. A lot of people forget this bond. So whatever it is that we're adding, you have to add an extra bond between that and the benzene ring. So it would be A. So let me just scroll up and highlight it. So, ta-da. Oh my goodness. My depth perception is non-existent. Any questions? Yes. We definitely can. There's just one more of these that I want to do, and then we can move on to the, oh my God, it's 1:40. Ah. Did you have a question, Eric, or did I imagine that? I imagined it. Cool. Okay. Okay, this is the other one. Nah. Aha, you can't even see it. What a wonderful day. It's a bones day for sure. Okay, so if you don't know what that means, it's a TikTok thing. Don't worry about it. So we have 2 functional groups here, and we have a COOH. What functional group is that? Carboxylic acid. So is that an activator or a deactivator? Strong or weak? Strong deactivator. Cool. So we have a strong deactivator. And what about SO3? That's also a strong deactivator. Which one? It is bulky, but okay, between these two, does it matter which one's the director? No, only because they both direct meta, and this position is meta to both of them. So a lot of students will just sit here and be like, okay, like look at the table or like look in their brain and find whatever. But in reality, you could do this really fast because you see that both of them point meta, both meta positions are the same. So the right answer has to be this guy. Yes. That's a carboxylic acid, so it looks like this. And if there's not specifically a carboxylic acid on the list, it's like with the carbonyls. So like a ketone, aldehyde. Coolio. So I'm going to get out of this. And we're going to run into the chapter 16. And then I realize I have done exactly what that girl in the beginning said, where we only covered chapters 15 and 16, but I guess that's how it be. I don't know. Someone for sure said it. Or maybe I made it up. That's also possible. Okay, so there's 2 types of Wittig questions. And I guess this one is the only one I'm seeing right now, so we'll do that one. Boop. Okay. An SI? Okay. Didn't know we were getting picky now. No, I'm kidding. Frickety frick. What a sad moment. Okay. Hold on. I got this. I'm very put together. I'm such a good SI leader. Don't worry. We can get. Don't laugh! 20. Okay. Yes, that's what, oh, it was 30. Okay. Thank you. Thanks. All right. So for this one, question number 30 is asking for V. We're going to ignore V because that's something we didn't talk about this semester. We're only going to try and find W. And I know I talked about this, but we're going to do it one more time because a lot of people get this question wrong because they're like, what the heck is this trying to tell me? So when we do this, we're going to split it up into 3 reactions. So this is reaction 1. This is reaction 2. And then this right here is reaction 3. So he could ask you this one of 2 ways. He could either give it to you like this, where he gives you the final product and he wants you to work backwards, or he could just give you the starting materials and ask you for the final product. So since this one's already drawn, let's do it. So he gave you the final alkene and he's asking for W. And if we look at it, W is reacting with PPH3 and C6H5Li. So he's asking for the precursor to the Wittig reagent, aka the illid. So you guys tell me, what do we react to get the illid? What do we react with PPH3? You gave the specific answer, and you're right, but I want the more general one. Yes. An alkyl halide. Cool. So the general reaction of making an illid is using an alkyl halide. So we want to figure out specifically what alkyl halide we use, right? And the way we would go about this is, in this one, he actually gives you the carbonyl that we used. So he's saying that if we see something like this, that's from the carbonyl. So that means this half was from the carbonyl. So we have to cut this guy in half. And we know that this part comes from the illid. So we're going to go backwards. And we get PH3. And if we go backwards, as someone said before, we're going to get this with some kind of halogen on it. Ta-da! Questions? Okay, let's do another one while we're here. Or someone's taking a picture, so I'll give it a sec. What? Yes. It's just sloppy. Okay. Scroll, 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 scroll. Okay, so this is the other type of question he could give you, where he gives you the starting material and you have to find the product. So what I like to do to go faster is, I know that these 2 steps make the illid, right? So instead of doing the intermediate and then going to the product, I know that I'm going to take this, bypass the intermediate, and we get, and this had 2 H's on it. So is everyone sort of kind of okay with how I skipped to the product there? Okay. So then this guy reacts with this guy. And we're just going to cut off the heads, stick the arms and legs together. So we get 2 H's on one side. And on the other side, we have a methyl and a benzene. So we have a methyl and a benzene. So the other part of this, the reason why a lot of students get this question wrong is they get to this point and they draw this out and then they have trouble converting it back to condensed formula. So be super careful. If it doesn't have a double bond, it's automatically wrong. So this is wrong and this is wrong. Now we just have to put the double bond in the right place. Here we have benzene, methyl, 2 H's. That looks good. This one we have a benzene and an H. That doesn't match. They flip-flopped something that they weren't supposed to. Here they have benzene and an H. Oh, you can't see that. So again, they flip-flopped something they weren't supposed to. So A is the only answer that makes sense. Did I go too fast or is that okay? Yay! Okay, so it is 1:50, and to answer something someone asked me way in the beginning, so I just have negative time. So unfortunately, I don't have time to do like a full 2-hour exam review this week. I apologize, but I do have my tutoring sessions from 3 to 4 today, and then from 5 to 8. So I will be here. I'm gonna try to record those. I will send you guys a link if the computers are working in the tutoring center. If not, I don't know. Last time it was a train wreck, so I'm not promising anything, but I do promise I will send you the cheat sheet. Other than that, I make no promises. But good luck if I don't see you before the exam. You guys are gonna do great. I believe in you.